Hello everyone. We are starting a free open lecture on our Discord. If you are a viewer and want to ask questions and get answers online, join our lectures. You can find the link to Discord in our Telegram channel. Now, let's move on to the code itself. Let's take a look at the code. The code seems very cumbersome, but in reality it is very simple. Let's look at the first function. This is the function that we will be calling. It is the merge sorting function for arrays. We have an array, and we call the split function on it. This is our initial action which splits the array. It then returns the merged array. So basically there are two actions. First, split, then merge. Now the question arises, how will it actually split? And so we turn to this. Split the array. So, accordingly, split the array. If the array length is 1, return the array itself. Otherwise, the first half and the second half split the array in half, meaning it also splits it in half and calls the split function itself. This way, as you can see, it calls to return the array up to the middle and the array from the middle to the end. It just takes two halves regularly and splits. There will be logarithmic splits. This is exactly what is written here. The next function we call is to merge. It calls the array, and what it does is we get the final array, which will initially be empty. If the array is odd, add an empty array. We add an additional array to throw in one of the elements for evenness. It's just that when we have an array, for example, with a single element, it can't just remain as a single element. We need to ensure that there is an empty one. In any case, if an array, for example, of one element is combined with an empty array, it will result in an array of one element. This is done to ensure there is an even number, making it easier for us to handle. Accordingly, it calls the array to add an empty array from 0 to the length of the array minus 1 in steps of 2 because it pairs the elements, and it sorts these arrays. The final array adds the current one. So, the question now is how it sorts. Here it is said to sort the array. It sorts using the algorithm we discussed. We have the first array and the second array, which come from the arrays I and j equal to 0 and the new array initially empty. We will be adding values to the new array. While the length of I is less than the length of the first array, and j is less than the length of the second array, if the first array with index I, that is the 0 element of the first array, is less than the first element of the second array, yes, that is under the j index. In this case, we just add the first element from the first array to the new array, and then move it. Otherwise, we add the new element to the second array, also j, and j is incremented by 1. Accordingly, we have covered this part, and these are the two tails exactly. These are two tails. And when we are left with one of the tails, we simply start adding these elements to the new array. So if our first one is already finished or our second one is finished, as long as this is possible.
Want to become a great programmer? Subscribe to our Telegram channel.
That's basically it. I think everything is clear with the pivot array here. And so we add the current array to the final array. If the length of the final array is 1, then we need to return the final array at index 0. Why at index 0? We return it, otherwise we will return the merged array to the final array. Why do we return it with index 0? Because we were working with lists like these. This is what we get. As a result, we ultimately get a list that contains only one list. Accordingly, to return the result and obtain a complete list, we essentially need to output the 0 index to the array R. This will be our resulting list. Therefore, we return the 0 index. And this is what we get as a result. This kind of list. Accordingly, if we refer to the code in Python, there will be just as many different notations, but the code will be identical. Accordingly, we have a list called array, which is equal to the split array, meaning we split the array, and we put into it the array from which we called the function, and we need to return the merged array. Accordingly, we return to the point where we are splitting, and in the splitting process, it tells us that we need to split the array. If the length is 1, just return a list of this array, that is, a list of a list with one element. So we have first and second, which tell us to split the given array into two halves, and then return the split from the first plus the split from the second. This way, it recursively starts dividing from the beginning to the center, and from the center to the end, splitting it into two parts. This entire splitting process is recursive with a time complexity of n log n. It seems like it's actually a logarithmic operation, but it's n log n because to copy from the center to some other point, it still uses n plus n divided by 2 plus n divided by 4 and so on. Accordingly, there will be n logarithms of splitting here, and the total number of levels will be logarithmic, just like in merging. Next, we move on to the merge function, which does the following. It tells us to create an entirely empty list. If the length modulo 2 is greater than 0, then accordingly add an empty one. If the count is odd, then add to make it even, so that the last odd one still has at least some. Empty pair. Accordingly, it says to sort this array and specifies which ones, that means both the current and the next one. Since there are two, we need to take the current and the next one with a step of 2, and it takes them in pairs. Accordingly, he will add the final array, current tells us, yes, that is, when he has sorted these arrays, these two arrays, he adds them to the list, and then he returns, that is, again, the merge of the final array, yes, and it will all end when he reaches the point where he has only one element. That is, it means one list inside our resulting list. In this case, it will already return the 0 index, and that will be our resulting sorted list. And this is how it merges. And accordingly, how it merges, just like in the pseudocode, we have first and second, yes, these are equal to our arrays. We have I and j, which are both equal to 0, and accordingly, we have a new array, which is simply an empty list. Accordingly, as long as I is less than the length of the first array, as long as I is less than the length of the first array, and j is less than the length of the second array, compare the first elements. The elements from I and the elements from j from each of the lists, and accordingly in this case, when first I is less than second j, then add first I to the new array, as it is smaller. Therefore, to keep the array sorted in ascending order, we need to constantly add the smaller element, and it says to add it and accordingly move the index to the right otherwise. Add the second one, i.e. the index from the second one and move the second one. And here it says that if one of them is essentially smaller, that is essentially, if there is any remaining tail, in this case we just add the tail, that's all. If either G and L2 or I and L1 become exhausted, it will simply append an empty list to it, in the case that this happens as a result in this scenario. Accordingly, appending an empty list will not affect the result in any way. Therefore, in this case, we can use this method. Basically, that's all. If we look at the C++ code again, there will be different variables, but the entire implementation will be identical. So we have our merge, which is called, we have our split array, and we have sort arrays, right? They are exactly the same. Accordingly, there are three analogous codes here: pseudocode, Python, and C++. These codes are written analogously, and accordingly solve the same task. Basically, we described this solution here, and you can check out the codes on our website, tfsp.ru yourself, so you don't have to rewrite them from the video. You can try running and testing them on your own arrays to see how it all works, debug, and understand it better. Thanks everyone for the lecture. See you at the next one.
Want to become a great programmer? Subscribe to our Telegram channel.